Hello, Internet! Today, we'll transform AI-generated images into 3D point clouds and bring them to life in TouchDesigner. But that's not all. You'll also learn how to control this audio-reactive composition using Playtron, creating an interactive, touch-driven experience. All right, before we begin, let's take a moment to review this level section by section, as it may become somewhat complex, given that it contains a large number of nodes. Overall, this is one of the most challenging tutorials I have created for the channel so far. Because of this, I want to approach it in a very structured and methodical manner so that you can follow each step without getting lost. So, as we proceed through each of these sections, I will clearly explain what is happening in each of them. Later, we will delve deeper into the specific details of each network, as it is there that I find it most crucial for you to understand what is going on and what kind of logic we are applying. All right, in this first section, we essentially have an operator that manages all the resolutions. This is a straightforward and intuitive setup. Next, in this section, I am using Platron MIDI. Here, you can see the entire architecture for leveraging Playtron, and you can even observe it through the webcam here. Playtron is also being used to control various audio elements. This aspect is honestly quite simple, but I do recommend watching another video that delves deeper into audio-reactive systems. I will provide the link in the description. This is our entire audio output. I'd like you to listen closely to what happens within these three sections and observe how Playtron is linked with the composition. Good. You just saw an example of what I am working on with Playtron. Essentially, I am controlling the camera, the type of point cloud data used, as I have several 3D point cloud active, and some additional effects. Moving on, the next block is crucial. This is where we structure the point cloud data. Essentially, I will be calling multiple point clouds with different files. Later, I will guide you through creating these from scratch, as you should know that this specific 3D content was generated using AI images that were subsequently converted into point clouds. This entire structure represents the main configuration that creates a particle-like system. A special shout out to Supermarket Salad, from whom I learned this technique. I encourage you to visit their channel, which has many fascinating things that inspired parts of this tutorial. Remember that later, when we create the network, I will explain in detail what is happening. Next, the importance of this entire network lies in the main point cloud instances section. Here, I convert the point clouds, which I referenced earlier, into instances. It's relatively simple, actually. If you don't know anything about instancing or cloning objects in TouchDesigner, I recommend watching this tutorial. The elements here are more secondary, like the instance spheres visible on the screen. Beneath it, there is a grid visible. In this section, we also have an output with a post-process component, which remains simple. A feedback mechanism ensures a motion blur-like effect during camera movements. There's also a bloom effect that is currently off, but you may opt to use it. This covers the core details. At the end of this tutorial, I'll briefly explain what I've done with the audio. If you would like to see the completed version of this setup, I recommend downloading the project from my Patreon. It includes several free point clouds files, providing ample content for you to experiment and create. Chapter 1. Transforming a 2D image into a point cloud file. All right, the first step is to create an image of whatever you want using any AI tool you prefer. You already know that I have a special fondness for using Midjourney. I've been attached to it since day one. Unfortunately, it's not free, so if you prefer a free alternative, you have a wide range of options available to you. There are literally hundreds of AI tools out there that can be explored. Essentially, what I will be doing now is working with Midjourney on their web interface. I will paste a prompt that I've already prepared in advance. One of the key aspects to keep in mind is that the background of the image must be black. This is crucial because when converting the image into a 3D mesh, we need it to be free of any background interference. Once we've generated the image, we just have to wait. Great, I'm going to choose this image here. It's interesting. Now, I'll just save it in my computer files. Up until this point, everything has gone smoothly. Now we'll use another AI tool. It's free up to a certain point, providing enough credits to experiment. The tool offers up to 200 credits, allowing you to generate a mesh from an image using just 20 credits. By selecting this option, you can see some of the things I've already worked on in the past. It's really fascinating. This was the image I used, and here's the mesh it produced, which we will use later in our workflow. Next, I'm going to upload the image I generated earlier. I'll wait for it to load. There's really nothing complex about this step. It's straightforward and quick. Press Generate and wait for it to finish. This may take up to 5 minutes. All right, we now have the final result. You can observe it both with and without shading. You can inspect how the mesh looks in play with some options over here. Just remember one important thing. When working with point clouds, people often scan real-life objects using their mobile devices, which is incredibly interesting. However, taking this inventive approach of creating something digitally from the ground up to later transform it into 3D offers a limitless array of possibilities. Okay, let's save this mesh as an FBX file format. Since we're using a free version of Meshy, we can't select many options, but that doesn't affect us for now. Let's discuss the files you downloaded from the mesh generator. Among these, the most crucial file is the FBX, as dragging this into your TouchDesigner will let you preview and explore the mesh in its entirety. What's even more fascinating is that this file can already be used as a coordinate reference for creating instances within your TouchDesigner network. It opens up a lot of potential for your designs and procedural art. But we'll take an extra step by converting it into a point cloud data file for further manipulation and customization. Remember that we also have a texture map associated with this mesh. This texture will play an important role later, so ensure you keep track of these two files. To convert the FBX or mesh file into a PLY file that behaves like a point cloud, we'll turn to Blender. Blender is a fantastic free software tool with a vast and supportive community. You can find countless tutorials on YouTube and other platforms, guiding you through almost any feature you might need. I often use it for practical tasks like what we're about to do, so don't worry if you don't know anything about Blender. Just download it and follow the next steps. First, drag and drop the downloaded file into Blender. You can choose to import FBX, and you won't need to adjust any settings unless necessary. As soon as you do that, the file appears in Blender. By navigating this icon circle, you can check if the file imported with its texture intact. If it did, that's great. Otherwise, ensure that everything is set correctly. Now, all you need to do is select the mesh. Next, go to the green triangle icon representing Mesh Properties. Minimize everything and, under Attributes, create a new attribute. Click the plus sign and name it Color. This new attribute will be associated with vertices, holding the color data. What we're doing here is essentially transferring the pixel color values directly to the mesh. To proceed, switch to Edit mode. Select all vertices of the mesh, pressing A, keeping in mind that it has a relatively low resolution at first. We'll want to subdivide it for better detail, so right-click, choose Subdivide, and increase the subdivision level to 2. This results in a denser mesh structure. Finally, head over to the Vertex Paint mode, ensure the correct options are selected. There might be some unexplained behaviors in Blender, but this approach works well for me. Then, navigate to the render settings in the small camera icon. Set the renderer to cycles, minimize irrelevant panels, and focus on the bake section. Under the output options, select active color attributes. This setup prepares everything necessary for our next steps. When ready, click Bake. You'll see the progress bar below, and it might take a few seconds to finish baking the colors into the mesh. Once complete, navigate to File, Export, and choose PLY as the export format. In the export settings, make sure Vertex Color is activated with sRGB values. You can choose to enable additional settings, but the primary goal is to generate a file containing the necessary point and color data. You can even open this text file to view the coordinate data if you want a deeper dive into how it's structured. Be mindful of the scale settings for TouchDesigner. I recommend using a scale factor of 10 for optimal compatibility. After naming and confirming your settings, click Export. To confirm the validity of this new file, open TouchDesigner. Bring in a point file and operator. Use it to import the newly created document containing all the exported data from Blender. Upon opening the file, you may encounter an initial error message due to default settings. You'll want to specify that the vertices data correspond to X, Y, and Z coordinates. Once verified, proceed to check that color data is also correctly exported. To further verify, create a point file select operator and configure 2 instances of it. In one, keep the default X, Y, Z settings. Attach a null operator to confirm it works. For the second, check that RGB settings are activated. If needed, link another null operator to observe color results. At this point, all the coordinate and pixel data will be available to TouchDesigner, which can read it as a texture. You can then use a geometry operator and set up the data as instances, reading it as spatial coordinates. To double-check everything, particularly if Blender occasionally exports corrupted data, use an online viewer or another compatible tool. By loading the exported document, you can verify that all vertex colors are correctly assigned. If successful, it means your data is accurate and ready for use in complex projects. Chapter 2, Network and Settings. All right, let's start with the fundamentals. We are going to create a constant operator. After that, we will create 4 channels, which are critical for our project's resolution settings. We'll rename each of these channels as follows: Global X, Global Y, Sphere X, and Sphere Y Perfect. Now, the most important element for this tutorial and the core of this project that we will construct revolves around this network for calling the point clouds files. Our starting point is to create a point file in operator, positioning it here to make space for the next operators. Then, we'll duplicate it 4 times as follows. Next, we need a point file select operator. This will be positioned above and subsequently duplicated 4 times. Following that, the entire batch of operators will be duplicated 4 more times. Now, moving forward with the first point select operator, we will connect it to a switch operator, positioning it here. We'll select the last 3 operators and connect them to the switch. Repeating this process for the lower section, we'll create another switch operator, positioning it accordingly. Selecting the 3 operators below, and connected all the operators as follows. This setup is perfect. At this point, it might be beneficial to bring the switches closer together since our network configuration will expand both above and below. Next, following the switch operator, we will create a null. This null will be named Original Position, and we'll replicate this process for the second null, naming it Original Colors. Excellent. Later, I will explain why this naming and structure are important. For now, let's turn our attention to the upper network. This network corresponds to our coordinates, and thus, it has a distinct structure from the network below, which will correspond to our colors. Let's begin by creating a classic feedback operator, one frequently used within TouchDesigner workflows. Connecting this feedback operator to a threshold operator, we'll position the latter at the top. Following this, we'll introduce a noise operator beneath it and connect it to a level operator. To complete the feedback loop, we'll place an add operator at the bottom. Finally, directly connecting the feedback and the last operator. An important step here is connecting the feedback operator to the second input of our noise. Finally, we will connect a null here. This node, which we will call feedback end, then create a texture 3D operator, which will remain disabled for now. At the very end, we will use a null operator, which we'll name positions. This null will provide the final coordinates and will be colored green for easy reference. Excellent. We have now completed the primary sequence for use as coordinates. Next, we'll turn our attention to the lower network, which focuses on vertex colors. While it shares similarities with the upper network, there are key differences. We will begin by creating a feedback operator, placing it below. Following this, we will create a transform operator, then a level operator, and finally create another add top. We'll connect the output of original colors here, aligning elements for consistency. Connect everything to a null, and then link it to texture 3D operator again. Then we'll also add a last null operator called colors, which will link using a green reference to indicate its purpose in mapping our instances. Let's move to the next step. For this step, we will create the main point cloud instances network. This structure will enable visualization of what we have created so far. As a side note, clicking the plus sign and pressing V allows you to see the point cloud file in use. While this is a default file within TouchDesigner, we will be using the files we were created specifically for this tutorial. Moving forward, create an add SOP operator, followed by a convert operator, and link it to a material operator. I believe you already have a sense of what's to come. We'll use a point sprite material, dragging it into the material operator. Next, we'll utilize a geo operator, as our 3D environment is relatively straightforward. This will involve a basic camera setup, leading directly to a render top operator. From the render operator, we'll connect a RGB key to have a black background and conclude with an out operator. This setup can now be activated, enabling the view and marking the completion of our primary structure. We must first load and visualize our files in TouchDesigner. Begin by importing your files. I have several examples already prepared. We'll start with the first file created during this tutorial, and then I'll use 3 additional files I prepared earlier. If you encounter any errors, simply select all files and reference X, Y, and Z as demonstrated. Pressing V again will allow you to see all the point clouds files. Perfect. Now, moving to the next step. Here, we created a bunch of point select operators. Remember, this network is for coordinates, while the other handles colors. Each select network will be linked to the appropriate select operator. Drag each file into these operators as follows. You'll notice that X, Y, and Z are selected by default. This can remain unchanged. We'll repeat this for the point select operators below, which control colors. Repeat the process. Select all 4 files and align red with red, green with green, and blue with blue. This ensures we obtain the color data from the file, specifically the color of each vertex in the point cloud. Okay, so each pixel within this texture corresponds to an RGB value, and by using instances in a geo operator, we can read these positions as coordinates in the 3 axes. Now is an opportune time to explain the mechanics of point clouds and how they function within this context. A point cloud is a collection of data points defined in a 3-dimensional coordinate system. These points represent the external surface of an object or a scene in a 3D space. Each point has a defined position in space, with X, Y, and Z coordinates, and may also contain additional information, such as color, intensity, or surface normals. Excellent. With this concept understood, our next step is to select the render top operator and adjust its orientation. Since I'm working vertically, I'll use this resolution. Continuing with our previous setup, remember that we created nulls for original position and original colors. But I forgot one thing. I realized we need to perform a mathematical calculation for the colors later. So let's insert a math operator here. Now for the best part, within the geo operator, select instances and drag the original position operator, assigning RGB to the corresponding positions. For instances 2, navigate to colors and reference the source operator here, again selecting RGB. Next, navigate to the add operator and activate the add points option. Within the convert operator, adjust the configuration. We now have our first glimpse of this shape, a fascinating initial result that seems quite interesting so far. Already, we can see many possibilities with these techniques. Next, we must correct our color vertex values. Remember, these values derive from the point cloud data. You can perform mathematical calculations or simply adjust the math parameters until you match the original color or at least have an approximation. The subjective nature of this process means experimentation is key. Let's see the other shapes adjusting the index of the switch operator and observe how different the colors it feels. Let's move the camera a bit. This configuration already looks well, and I'm inclined to move forward. Remember, you can use math parameters, allows for fine-tuning of colors until they meet your desired specifications. Whether working in black and white or high saturation colors, if you wish to explore additional color adjustments, you can introduce a level operator later. For now, we'll maintain focus on this configuration. Another option involves adjusting the size of points within the sprite point material. Increasing their size creates a shading-like effect through vertices. I'll leave this setting at 2 for now. Moving to the switch operator, we can explore different shapes. Remember, not all configurations will work the same, so you will need some tweaks. Before we move on to the next segment, let's recall the textures we obtained from the FBX file. I've imported these textures from my computer and arranged them in their intended order of use. Each texture corresponds to a specific point cloud we created earlier. To maintain a consistent structure, we'll create a new switch operator and connect these textures to it in the same order as before. We'll place this switch operator below the others and name it Color Textures. To clarify, these textures won't be mapped directly as we initially expected. Instead, they'll serve as experimental effects on colors, creating a more contrasted look. Feel free to use them or not, based on your needs. Remember, they're not tied to individual points within the coordinate system. Rather, they add a superposition texture layer. I'll overlay these textures because I think they work well together. Within the point sprite, you'll find a color map option. Once applied, the results are noticeably enhanced. If I activate all the switches, I can see how these textures affect the entirety of the 3D point cloud shapes. This approach yields improved visual results across multiple textures. Returning to where we left off, I'd like to create some movement in the size of the particles. So let's do the next network. Create an LFO operator here, then connect a math operator. Then use a lag operator for smoothing all the values. Our parameter selection here is easy, just setting the math range between -1 and 1, and finally set the out range between 2 and 4. Let's call this operator size points and map the values to this parameter. I may decide to reduce their size slightly. Temporarily, I'll deactivate this mapping, but keep in mind that their presence within the network remains for later. Next, let's delve into explaining the most intriguing network segment. This is where much of our manipulation occurs. To begin, I'll select these two operators and mark them in red, since they represent areas where numerous parameters will be adjusted within the feedback network. If you notice that all the operators appear empty, simply apply a pulse to refresh the calculations. Our focus will now shift to the use of this entire network. We're going to replace the previous mappings with the ones we are finally going to use, which are highlighted in green at the end of the network. After completing these replacements, you'll notice that the coordinate positions have changed drastically due to their interaction with the feedback, noise, and threshold operators. Also replace the second operator for the colors. Now, create a keyboard input operator to continuously reset the feedback. Controlling the feedback reset is essential, especially when making adjustments. This step ensures you can observe the transformations within TouchDesigner as they unfold. Let's discuss the role of the threshold operator, which plays a pivotal role in shaping the network's behavior. So I will explain how it works. The threshold top is used to convert an image into a binary, black and white image by setting a cutoff point. Any pixel value above the threshold becomes white, or a specified value, while any pixel value below the threshold becomes black, or another specified value. This is useful for creating masks, isolating specific areas of an image, or generating a high contrast effect. If we use this threshold and move it, we see that it shifts like a cut, where manipulation of coordinates only occurs in that specific cut and part. For example, if I choose the red channel, it will apply only to the data that have red. If I choose green, it will be different, and each color corresponds to an axis. For now, I will leave it on luminance and set it to 0.5, as I know it is affecting there. Then, we move to the noise operator, select it, and it's important to enable monochrome mode because we want to use the entire color palette. We can start by eliminating harmonics, removing the offset, and when we manipulate the amplitude, we notice that it distances particles from their original coordinates outward across all three axes. The exponent will have a more or less opposite effect. This is very interesting because when we apply feedback, you will see the effect we can achieve. Right now, the feedback is not doing anything. We will reference this direct feedback and reset it. We see it is now functioning, but currently, the parameters are too powerful, so we need to adjust them. For example, increasing the exponent and adjusting the amplitude. You'll notice that it creates a cut that immediately separates the coordinates, moving them away more than I'd like. To fix this, I will keep adjusting the threshold until it reaches a point where the image doesn't completely disappear. Now, this is interesting. Moving on to the noise operator again, I can start tweaking the amplitude. It looks pretty good. I'll leave it at 0.5 for now. And with the level top, I can adjust the opacity for more or less feedback effect. So far, it's working well. As you can see, the particles start to disperse. And if I change the threshold to any other color, it will behave differently. Let's leave it on luminance for now. I almost forgot something important. Select the noise operator, and in the output settings, use the option input times noise. Select the threshold operator again and adjust the values. You will notice that even a slight movement can significantly change the final result. I'll adjust the threshold and experiment with broader values. Let's try setting it to -24. That seems good. Going back to the noise operator, we can tweak the amplitude further or change the exponent. If I don't want the particles to spread too far, adjusting the noise period helps keep particles either widely dispersed or closer together. Setting it to 30, for example, creates a dramatically different effect with a distinct logic. This is visually captivating. And rotating the z-axis in the camera, using the classic expression abs time.seconds times 30, we can achieve a constant rotation that allows us to view the particles from different angles. I'd also like to show you some switch changes. But before, let's create another mapping for the keyboard. I will use the number 2 key for this. Create a select top. Select only the reference corresponding to the number 2 keyboard. Connect it to a count operator with a minimum of 0 and a maximum of 3. Then reference this count across the switches here. Now I can switch between different forms visible here. This is the one we created in Midjourney. Moving forward, there's a trick I learned from Supermarket Salad, creating another series of operators to keep the original form closer to how it started. Since the feedback particles continuously function, it's ideal to maintain some of the original shape. To do this, I'll set up a sequence as follows. Create a noise operator here. Connect another threshold, and add a select operator. We'll also introduce a multiply and connect them in this order. Next, create an over operator. Here's what will happen. The select will grab the original positions and mix them with a multiply operator. So reference the original position null to the select. Select the noise and use the following parameters. With the threshold value set to 0.99, you can effectively control the original shape. Finally, connect the new setup to replace the feedback end. Upon resetting, particles spread while the original form remains more intact. Increasing the threshold and tweaking the noise harmonics helps. If the shape becomes too granular, reduce noise values slightly. You can reset the feedback as many times as needed until you find a point in the composition that you like. Perfect! For the network below, we'll also use feedback to subtly shift the colors of each vertex. Don't forget to map the key one that we're using to reset this second feedback as well. First, select the transform and animate the x-axis using the expression we always use. Next, locate the tile option and set it to repeat for continuous movement. I'll divide it by 30 because I want a more subtle motion. Finally, reference the add operator within the feedback and adjust the opacity to fine-tune the amount of feedback we want to achieve. Perfect. Now we have colors assigned to each coordinate with a subtle movement that will feel better if we use slightly larger points. This step is optional and very subtle, so you can continue experimenting with other operators to see if you achieve more contrasting results. The final effect uses a cache to create a unique trail effect. Using the texture 3D top with a cache of slices captures different moments or states of the visual. When mapped to the instances of a geo, this creates a trail effect as the slices are spatially distributed, displaying a progression over time that follows the movement of the instances. I will use a cache size of 9 and activate the operators. After this, to properly see the effect, we need to reset the feedback. Now, as you can see, we have a trail effect that corresponds to 9 overlapping layers of previous information stored in the cache. So far, so good. This tutorial has become quite extensive, so I've decided to continue the integration with Playtron and audio in a second entry. Please reach this point and leave any questions in the comments before moving forward. I also recommend subscribing so you don't miss the next